Well, hello everyone. Welcome to episode 6, part 2 of our series on compute infrastructure. Now, if you recall, last episode we talked about containers and microservices and that virtual machines virtualize the hardware to run multiple operating systems. Containers virtualize the operating system to run multiple applications, and that we use microservices to modularize applications into smaller building blocks that can improve development times. In this episode, we're going to talk about composable infrastructure and serverless computing, so let's get started. So what exactly is composable infrastructure anyway? Well, aside from being a peculiar sounding word, it's referred to as a system design principle, and it deals with the interrelationship of the components and the resources that make up the system. So a highly composable system provides components that can be selected and configured in various combinations that satisfy user requirements. Now, when we bring that into the data center, composable infrastructure eliminates the need for having workload-specific environments, such as having an environment for VM and having an environment for bare metal. It does this by providing a fluid set of resources. This would be your memory, your storage, and your fabric, and these are dynamically configured to meet the requirements of any application. Now, these resources are abstracted from the physical locations in the same way virtualization does, but it's the entire environment, and it's controlled through a single unified management interface that integrates all of the infrastructure and operations, and this gives us the ability to run physical workloads in the same exact environment that supports both virtual and container-based workloads. Now, you might be asking yourself, how is that different than converged infrastructure and hyper-converged infrastructure? Because certainly in the case of CI, you can run bare metal and VMs on the same platform. But first, the ability to support bare metal and virtual and container-based workloads all on that same infrastructure isn't possible with CI or HCI. And another key difference is managing excess and or stranded capacity. So for example, if you need to add more storage in CI or HCI, you need to do this in lockstep. So in most cases, you actually have to add compute and memory at the same time because you have to add resources in increments of full server nodes. And that capacity doesn't become available to any other workload that could possibly use it. Now, composable infrastructure addresses this by disaggregating the underlying compute, storage, and fabric. And what disaggregation means in this context is you're able to scale each individual resource independently. You're not forced to add unnecessary resources. So, for example, if you just need to add storage, that's all you're adding is storage. Now, this results in workloads being able to pull resources from a single pool when needed. And when we layer on APIs, we actually create some automation in that environment, and you actually do the automatic resource pooling and pulling. So in other words, if you need more resources, you can automatically go and get them. And that provides a true cloud experience within a client's own data center. So what does this mean from a practical standpoint of view? Well, simply put, you're going to save money because you're eliminating the silos of having those separate environments, but you're also eliminating the need to add stranded capacity. So you don't need to add memory and compute if all you need is storage. You just add the storage. So when a client thinks about upgrading aged infrastructure, composable infrastructure should be a consideration. Now, there are sizing considerations to think about that we don't have time to cover in the podcast. So do reach out to the CTO office and we'll get you whatever information you need. So moving into serverless computing, this is a relatively new computational model that's gaining adoption in public cloud environments. And what it does is it eliminates the need for provisioning and management of the infrastructure. So instead of managing infrastructure in serverless computing environments, the I&O teams, the data center operations team, they have a different job. They now have to make sure that you have stable configurations and that you're optimizing costs, because remember, this is a metered service that runs in public cloud. And you also have to monitor the platform and execution environment to ensure that the SLAs are being met. Now, in a serverless environment, the application is packaged into units called functions, and these functions execute as a service and they're triggered by some sort of event. So a good example of this is IT automation, where you have some sort of IT automated task that has a trigger, such as patching or backup, or it could even be monitoring service. Another example is stream processing for IoT. These are environments that require real-time processing, but it may not always happen all the time, so it's another good candidate. And another good candidate for it is voice-enabled processing. So any of you that have Alexa or Google at home, you're using serverless computing. So when you say the trigger phase, hey Google, you're actually triggering an event which invokes a function to run in public cloud. And it has to perform very, very quickly. So we have functions. These are triggered by events and they're executed as service. How is that different than virtualization or VMs and containers? Well, let's go back. Remember, virtualization abstracts the hardware to run multiple operating systems. Containers virtualize the operating system to run multiple applications. In serverless, we're actually virtualizing the runtime. That is, we're using events to trigger the execution of code as a service. We don't know where that service runs, just that it does, and that it has to perform within a given service level agreement that we've defined. Now, as I've mentioned, this is a relatively new and nascent technology, and we are seeing examples where the platforms are out there. So AWS was the first to launch Lambda in 2014. Microsoft has a service. They've got a platform as well. It's referred to Azure Functions. IBM's is referred to as Cloud Functions, and there are others in development, such as Google Cloud Functions, which is currently in beta. Pivotal has what's referred to as a function services, and Oracle acquired the people from an organization called Iron.io to incubate theirs. Now, there are some successes of where people have used serverless that are worth mentioning, and one that we can probably all identify with is from Autodesk, and what they used serverless to was to automate the onboarding and offboarding of user accounts. Now, that process used to take them 2 weeks, and it's now been cut down to 10 minutes, which is pretty impressive. And what they cite is reduce cost, improve time to value, obviously because the people can use the accounts earlier, and operational simplicity is the key benefits. Another good example is FINRA. This is a financial regulatory organization that's non-governmental. And they're using serverless in a different way. They're using the metered model to reduce cost. Since they no longer have VMs sitting on standby. Since in the metered environment, you only pay for what you use. They've also eliminated all the time they were spending, and I guess it was significant, managing Amazon machine images. So that's now gone. Now, a final comment I would have on serverless computing is this is a technology that hasn't even hit the peak of inflated expectation on Gartner's hype cycle. So this has a long way to go before we see it adopted in a mainstream way. However, having said that, what will drive that adoption is increased use of public cloud, which we know is happening, but also the use of AI and IoT edge computing. So it is something we need to follow closely. Well, this is an awful lot of information to cover in one episode, but let's recap. We have Composable Infrastructure, which gives us the ability to better manage compute, storage, and fabric resources in the infrastructure, and we're using resource pools in which to do that, and it's controlled through a unified management system. Serverless computing provides us with the ability to execute services that are triggered by events, and it runs in public cloud. Now, I hope this was informative and it clarified what the differences between composable and serverless are. We're going to wrap up the series with part 3 to talk about automation orchestration tools and how they've actually advanced to address these new technologies. Because when you think about having a lot of services running, and when you think about containers and microservices, you need to have a pretty sophisticated set of tools to actually manage those environments for us. So as always, I welcome your feedback and suggestions on other topics. So with that, enjoy the rest of your day.